Hello students, this is our review of chapter 13. You can follow along on pages 226 to 228. Before watching this video though, you should already have been through this review and actually already checked over your answers. So some of this I may go through quite quickly because you should be pretty familiar with it, but I will take some time on every question. Remember that you can always pause if you need to and even go back and rewatch my explanation of a question. Let's start with this vocabulary. A triangle with two equal sides. That's one of the definitions that we learned about isosceles triangles. Isosceles has two equal sides. Ooh, sorry about that dreadful handwriting. See if I can do better with a triangle with three equal sides. That is an equilateral triangle. Equilateral. A little bit better handwriting-wise. A triangle with one right angle. Answer's right there for us. That is a right triangle. And you'll notice that the list that you had, I should write triangle after each of these. But again, just to save time, I'm just going to write that first word. A four-sided figure whose opposite angles are equal. There's two answers to this one that we looked at. The first is a parallelogram. Parallelogram. And the second one is a specific kind of parallelogram, a rhombus, which is a parallelogram that has all four sides that are of equal length. A four-sided figure with only one pair of parallel opposite sides. So instead of two, like in these, a trapezoid has only one pair of opposite sides that are parallel. Now in this section, we need to identify the triangle in two different ways after identifying the measures of the different angles. This one we can see from this that these two angles are equal to each other. Because remember, in isosceles, a triangle with two equal sides, angles opposite of the equal lengths are equal to each other, which means B is equal to 65 degrees. And 65 plus B would be 130, which means A is equal to the total 180 degrees minus the 130 made up of B in this angle, leaving us with 50 degrees. And this is an isosceles, obtuse, acute, or right. It's acute. All angles are acute. Isosceles, acute triangle. Moving on to this one. We can see right away this is a right triangle. And let's see, if that's 43 degrees, angle C is equal to 90 degrees minus that 43. And why am I doing 90 instead of 180? Because in a right triangle, 180 minus 90 leaves 90 degrees that these two angles have to make up. So angle C is equal to 90 degrees minus 43, which means that C has to be equal to 47 degrees. Now the question is, we know it's right, and it's not equilateral, but is it scaling all different lengths, or is it isosceles? If you were thinking scaling, you're correct. If it was isosceles, these two angles would have to be equal to each other. So because they're not, must be scaling, and it is right. Triangle. It's right up there too. All right, number 8. We just need to find out this angle. Ooh, it is isosceles, which tells us that two angles are equal. Are these the two that are equal to each other? No. These two are. So let's figure out what that angle is, 60, which means D is equal to 180 minus 120. Angle D has to be, oh, that's actually also 60 degrees. Ooh, and if all angles are 60 degrees, what kind of triangle is that? Equilateral. Is it right, obtuse, or acute? Acute triangle. And on to our final one. This one we just have to add up all the angles and subtract them from 180. So E is going to be equal to 180 degrees minus 120 and 23. There's 143. Means that E has to be equal to 37 degrees. So this is scaling, isosceles, or equilateral. Well, those are all different angles, which means that it has to be scaling. And obtuse, because we have an obtuse angle. Obtuse triangle. All right, let's move on to question 10. I drew this triangle mostly to scale, but you'll need to get out a ruler to measure it. I won't make you watch me measure it, but AB is equal to 3 centimeters, BC is 5 centimeters, and CA is 6 centimeters. And remember, this is useful because we learned the property that the sum of any two sides has to be greater than that third side. So AB plus BC is greater than AC. Same for this one and that one. If any of those were untrue, we would not be able to see a triangle here because they would not, the lengths would not work out. In this one, we need to identify what's a rhombus and what is not. These are all different shapes that we have looked at, but they're not all rhombuses. Is this one a rhombus? No. Why not? It meets the requirements of having two parallel sides, but this side is longer than that one. I can get the ruler out and prove it, but because those sides are not equal, that is not a rhombus. It is a parallelogram. This square, you can see my shaky hands, but I've got two sets of parallel sides, and each of their lengths are the same. So yes, this one is. Same here, it's not a square, but all of these lengths are the same length, and they're all there are two sets of parallels. This one should be a pretty quick, that's a trapezoid. These are definitely not the same length, and they're definitely not parallel. So just this one and that one are our rhombuses. 17 to 22, we're doing some more math and figuring out the different lengths of these, or the different angles of these triangles. This one, A, well, if all three of them, this is an equilateral, which means that each angle is the same size, so A has to be 60 degrees. The measure of angles in an equilateral, no matter how big it is always 60 degrees. Number 18, this is a right triangle, which means these two together have to be 90 degrees. So B is equal to 90 degrees minus 45 degrees, which is also equal to 45 degrees. Ooh, which means this is actually an isosceles triangle, because those two are equal to each other. Moving on to 19, speaking of isosceles, these two have to be the same size, but I don't know how big it is. Well, how much of the total is this 7 degrees taking up? 180 minus 70 leaves 110 degrees to be shared equally between these two, which means C is equal to 110 degrees divided by 2. That's equal to 55 degrees. Let's look at this one. Your instructions in your book tell you that this is a parallelogram, which means that these two angles are equal to each other, these two are equal to each other, and adjacent angles add up to be 180 degrees, which means x plus 60 has to equal 180 degrees. So 180 minus 60 leaves 120 degrees as our answer for x. That's a pretty big angle, but we can see that's obtuse, so that seems to check out. 21, we're told this one is a rhombus, which means that all of the lengths are the same, and just like in this parallelogram, opposite angles are equal to each other, so this is also 114, and adjacent angles add up to be 180 degrees. Let's for a second, though, look at this shape here, this little triangle. We can see this is an isosceles, which means this angle is equal to that angle. Same thing over here. If this is isosceles and this is 114 degrees, y plus this angle plus that one is 114, and y is equal to itself. So 180 minus 114 degrees is equal to 66 degrees, which means that two y's have to equal 66 degrees, which means y equals 66 degrees split between those two, means that y has to be 33 degrees. And then finally we have this trapezoid. Your instructions tell you that this is a trapezoid as well. Remember, in a trapezoid, opposite angles are not equal, and not every pair of adjacent angles will add up to 180. But there is one pair, or excuse me, there's two pairs that add up to be 180 per trapezoid. the sides that are next to each other but not on the same parallel line. So these two, oh, and these two. How convenient. So Z has to be 180 degrees minus 125 degrees, which leaves 55 degrees for Z. All right, it's just a few more questions. 23. Two sides of a triangle are 10 inches and 20 inches. What lengths between 20 and 25 do not work? So I changed the wording up a little bit from what's in your book, but it's the same question. So remember that rule we talked about before. No two sides can have a sum that is less than the third side. So let's figure out what does not work. 10 plus, ooh, that says 20, but it should say 12. Pardon me. 10 plus 12 is equal to 22. So 22 and larger will not work. And we want to know which numbers between 20 and 25 will not work. Will 22 work? No. If one side was the length of 22, it would look like that. It would just be a flat line where they just meet each other. So these need to be greater than the other length. So 22 doesn't work. 23 would be even worse. 24 would be worse. And they want to know the answers between 20 and 25, so I don't have to keep on going. So actually, 21 is the only length that does work between 20 and 25. But what they're asking us for is which ones do not work. So 22, 23, and 24 are no good. All right, 24. They tell us some specifics about this. This is a parallelogram, and we need to find this length. Well, if I know that this is 70 degrees and that this is isosceles, these two angles have to be equal to each other. And they have to be whatever 180 minus 70 degrees is. 110. So together, these two equal angles equal 110 degrees, which means each one is 110 divided by 2. Each of these is 55 degrees. How does that help me? What else do I know about angles in a parallelogram? I know that this angle plus this entire angle has to equal 180 degrees. And actually, I've already done part of that problem up here. 180 minus 70 equals 110. So this entire thing has to be 110 degrees, so that 70 plus this angle equals 180. If I know that this part of it is 55 degrees, then all I need to find is what's left here to make this entire angle 110. 110 minus 55. That's actually also equal to 55 degrees. So this has to be 55 degrees too. All right, so let's look at this one. This one we're told that the entire shape is a trapezoid, and our parallel lines are these two. And we need to find two angles, Z and Y. Well, this is an equilateral. Right off the bat, I know that these are 60 degrees. And how do I know that this is an equilateral triangle? Because of these lines. They tell me they're all equal to each other. What else do I know? Well, if it's a trapezoid, then there are some pairs of angles that add up to be 180 degrees. These two and these two. Ooh, and this is already 90 degrees. I can see right away because it's a right angle. So 90 degrees plus this equals 180, which means that 60 plus whatever this y is has to be the other 90 degrees. Because this 90 plus this 90 degrees equals 180. And I know that 60 degrees comes from here, but how much is the y contributing? Well, if 60 plus y is 90, that y has to be 30 degrees. But I also need to find this z. And at this point now I know two parts of this triangle. I know this is 90. I know that that's 30. So what does this z have to be in order to make all three of these angles 180? That actually also has to be 60 degrees. So 30 plus 60 plus 90 is 180. And there's a nice way to check this one. 60 plus 60 plus 60 is 180 degrees. So these three angles are also 180 degrees, which, because it's a trapezoid, we know has to be true. So Z, and this one is 60 degrees. All right, home stretch, last one. We are told that there is both an isosceles triangle and an equilateral triangle in this shape, and we need to find out what this X is. If we know this is equilateral, we know that all three of these angles has to be 60 degrees. If this is 32, we know that this plus these two larger angles has to be 180. So let's figure out what these two larger angles have to be if this is 32 degrees. 180 minus 32 degrees is equal to 148. So 148 degrees is these two large equal angles added together. And if they're equal, I can figure out how large each of those actually are. 148 degrees divided by 2 is equal to 74 degrees. So what that means is, again, this larger angle and this one here, those are 74 degrees. And how does that help me? Well, if this entire thing is 74 degrees and this part here is 60, what does X have to be? 74 degrees minus 60 degrees equals 14 degrees. X has to be 14 degrees. Again, I hope that you actually have some fun with these. They kind of feel like little mini problems, but I know that was a long review. If you have any more questions, make sure that you're ready to ask them tomorrow during our Zoom session. Thanks for hanging in there, and I'll see you tomorrow.